Yes, hi everyone. So welcome back to Power Systems 2 online series, and we are in the third unit, that is performance of long transmission lines. And in previous class we solved some problems. That is two problems we solved. That is how to find ABCD constants of long transmission line. We solved those two problems, and today we see one more interesting concept. Say one more interesting concept, that is how we see the voltage as wave. And we know that wave, in the sense, the wave can be incident, the wave can be reflected, and the sum of incident and reflected is to be considered as the refracted. So like that we have the wave system. So therefore, how we see in transmission line, that too especially long transmission line, how we observe the phenomenon of incident and reflected. So now you keep side heading, escape side heading, incident and reflected waves. The concept of incident and reflected waves. Concept of incident and reflected wave. Okay. Yes, I think already we derived the expressions for ABCD constants of long transmission line. While we are deriving, so we had one equation for voltage. Just go to the equation 9. I think it is equation 9. Yes, what is that equation 9? In the sense, you can see that V is equal to 1 by 2 into VR plus IR into ZC e power gamma x x plus 1 by 2 into VR. Just let me write like this: VR minus IR into ZC by 2 into by 2, this is 2 into e power minus gamma x. And we know where ZC is the characteristic impedance, and which is given by square root of L by C for lossless transmission, and gamma is equal to square root of YZ, like that we know. And here x, in the sense, x is the distance from receiving end. That is, if it is receiving end and this is sending end, and here we have taken one element, this is element, and the distance from receiving end to the x is called the distance between receiving end to the element is called x. Suppose if you observe the voltage equation, it is having the two components. This is first component, and here it is second component. First component, second component. These two components are depending on the variable x. If we increase the x, the first component is increased and the second component is decreased. If we increase the value of x, the first component is increased and the second component is decreased. So if suppose why the component is increased and decreased, if we see, suppose this is as the voltage components are depending on the x, and as the x is increases, as it is the exponential term, it will be like waves only. It is like wave only. And this out of these two components, one wave is incident wave and another one is reflecting wave. One wave is incident wave and another component is reflecting wave. Suppose I have incident wave. When I incident the voltage from sending end, so with great magnitude, it will reaches the receiving end. That means starting high magnitude at ending low magnitude. This is incident. So if you increase the volt x value, so which component is increases? If you increase x value, which component is increases out of these two? Just you see, the first component is increases. That means what you say, when you increase the x value, the first component is increases. First component is increases. That means as the x is increases, it will go to the sending end. It will reaches the sending end. So hence, as the value of x increases, the voltage component is also increases. So and it is very near to the sending end. So hence it is called incident voltage. Hence it is called incident voltage. And if you observe the second component, in the case of second component, what happened? As the value of x is increase, the component value is decrease. The component value is decrease. Yes, the component value is decreased in the sense, initially at receiving end, it is having the great value. When x is equal to 0, it is having the great value. That means as x is increases, the wave is reflected and its magnitude is decreased. So therefore, once again I will tell you, so how to write in the examination. In the examination, so don't write from equation 9 like that. We have to derive up to equation 9. So as we derive in the case of long transmission line, ABCD constants derivation. Yes, after that, from the above equation, that means from the voltage equation, you can write as how you can write in the sense, you can represent the same manner in your examination also. That's how you represent in the sense, the first term in above equation is called incident voltage wave. Yes, what is that? The first term in above equation is called incident voltage wave. Yes, why it is incident voltage wave? As its value increases as x is increased. As its value increases as x is increased. Since we are taking receiving end as the reference, and as x increases, the value of voltage increases. That means a voltage wave is decrease in magnitude as it's travel from sending end towards the receiving end. Sending end towards the receiving end. That is why this part of the voltage in the above expression is called incident voltage. That means from sending end to receiving end, the voltage magnitude is decreased. From receiving end to sending end, the voltage magnitude is increased. So therefore, it is called incident voltage. Yes, for similar reason, the second part is called reflected voltage, as its magnitude, as its value decreases as x is increased. As its value decreases as x is increased. Okay, so at any point along the transmission line, the voltage is the sum of these two components. What are the two components? Incident and reflected voltages. As the current expression is very similar to the voltage, the current can also be considered as the sum of incident and reflected current waves. So hence in the examination, when they ask, yes, in the examination, when they ask to find what is reflected voltage, what is incident voltage, in the sense we can write this equation very simple, that is incident voltage. V incident. Generally, in some textbooks they used to prefer this as V plus, like that. V plus stands for incident voltage. So which is given by VR plus IR into ZC by 2 e power gamma x. This is incident volt. And similarly, we can represent reflected voltage. V reflected. V reflected. This is V minus. V minus. What is equation for V minus in the sense? It is equal to VR minus IR into ZC by 2 into e power minus gamma x. E power minus gamma. So these are incident voltage and reflected voltage of long transmission line. The sum of these two is refracted voltage. Refracted voltage. So now let us solve one problem. Yes, let us solve one problem. So write on that. A single phase, a single circuit, a single circuit a single circuit 50H 3-phase transmission line has the following parameters, per kilometers. Yes, he has given the value of R. R is equal to 0.2 ohms. L is equal to 1.3 millihenries and C is equal to 0.01 microfarads. 0.01 microfarads. Yes, next. The voltage at the receiving end is 132 kilovolts. Voltage at receiving end is 132 kilovolts. If the line is open at the receiving end, if the line is open at receiving end, find the RMS value and phase angle of the following. of the following. Yes, the first one. The incident voltage to neutral at the receiving end bracket reference at the receiving end. Second one, the reflected voltage to neutral at receiving end Next, third one, the incident and reflected voltage to neutral 120 kilometers from receiving end. Yes, there are three things we need to find, and in the three cases we can observe one thing, that is voltage to neutral, incident voltage to neutral, reflected voltage to neutral, incident and reflected voltage to neutral. Yes, what is that mean? Yes, to neutral in the sense it is line to neutral voltage. Line to neutral voltage is phase voltage. Line to neutral voltage is phase voltage. Yes, he asked to find the phase voltage of in three cases. Okay, so first let us write the given data. Yes, what is this impedance? Z is equal to, this is small z, is equal to small r plus small j into x. He has given all values. Yes, what is small r? Small r is 0.2 plus j. What is x? J omega l. Omega in the sense 2 pi f. F in the sense he has given 50 H. Two pi f into L. L in the sense 1.3 to 10 power minus 3 because it is milli. Therefore this value is 0.2 plus j 0.408. Or you can also write in polar form as 0.458 at an angle of 63.88 degrees. Okay, then what is shunt admittance? Shunt admittance, small r indicates resistance per phase per kilometer because as he did not given the value of the length, and he mentioned that the following parameters per kilometer, like that. Okay, the shunt admittance small y is equal to j omega c. This which is given by j into 2 pi f into c is 0.01 micro into 10 power minus 6, and this value is 3.14 into 10 power minus 6 at an angle of 90 degrees. Yeah, this is Siemens or Mo. And then what is characteristic impedance? Characteristic impedance, that is ZC is equal to, what is equation for ZC? Square root of Z by Y. Therefore this is 0.454. At an angle of 63.88 divided by, what is value of Y? 3.14 into 10 power minus 6 at an angle of 90. Yes, this can be written as yes, this is approximately 380 at an angle of minus 13.06 degrees. Yes, I told you already in my previous lecture. Yes, how to find square root of complex value number, square root of complex value, how to find, we already saw in the previous lectures. Next, what is gamma? Gamma is square root of yz, square root of yz. Square root of yz. Okay, now you substitute this value. That is gamma is equal to 3.14. Gamma is equal to 3.14 into 10 power minus 6. This at an angle of 90 into Z value is 0.454 at an angle of 63.88 under the road. Okay, therefore if you calculate this value, then this will be like this: 0.2714 plus J 1.169, this into 10 power minus 3 is there. And here you can see this is the value of alpha and this is the value of beta, alpha and beta. Okay. And what is the receiving end voltage? He has given the receiving end voltage. VR phase is equal to, that is 132 kilovolts, 132 thousandths divided by root 3. Then how much this value? 76200 volts approximately. 76200 approximately. This is it, right? Check once. 132,000 divided by root 3. Yeah, this is 76200. I think it is 76210, like that it will come. Uh, yes, just to check the values. After that means I am keeping the error as 10. Error is 10. That is 76210, like that you will get. But I am taking this as 76200. You correct all values after completion of the problem. Yes, very good. Now he has given one condition. What is that? The receiving the transmission line is open circuited. The line is open at receiving end. The line is open at receiving end in the sense which current flows through the receiving end? IR. IR is equal to 0. Yes, right here. As the receiving end is open circuited, the current flowing through the receiving end is 0. So hence IR is equal to 0. Okay. Next. Yes, first what he asked? He asked to find the incident voltage to neutral at receiving end. At receiving end in the sense X is equal to 0. Then what is the equation for incident voltage? V plus is equal to. Yes, what is V plus? VR plus IR ZC by 2 into e power gamma x. Just you substitute x is equal to 0. X is equal to 0 in the sense this term is 1. That term is 1. And we know that IR is also 0. IR is also 0. Hence, V plus is equal to VR by 2. V plus is equal to VR by 2. Yes, VR by 2 in the sense you know what is VR. 76200. Yes, hence this will be 38100 volts. 38100 volts. Okay. Next, what is second one? Similarly, the reflected voltage to neutral. That is the reflected voltage to neutral at receiving end. That is second one. The reflected voltage to neutral at receiving end. That means X is equal to 0. Yes. Reflected voltage in the sense V minus. V minus is equal to VR minus IR ZC divided by 2 e power minus gamma x. So here also you can substitute x is equal to 0 at receiving end. And IR is equal to 0 as the receiving end is open circuited. Yes, hence V minus is equal to VR by 2 only. This is 38100. You can observe that at receiving end the incident voltage as well as reflected voltage both are same. Incident voltage as well as reflected voltage both are same. Okay. Next, what is third one? Yes, what is third one? The incident voltage at a distance of 120 kilometers from the receiving end. That means here you need to substitute the value of x. X is equal to 120 kilometers. X is equal to 120 kilometers. Yes, when x is equal to 120 kilometers, then what is VR, receive incident voltage, and what is reflected voltage. X is equal to 120. Then incident voltage, what is equation? V plus is equal to, as IR is equal to 0, therefore you have only VR. That is VR plus IR into ZC by 2 into e power gamma x. E power gamma x. Or you can also write this as gamma is equal to alpha plus j beta. Alpha plus j beta. Yes, alpha plus j beta in the sense that is V plus is equal to as other just show substitute VR is IR is equal to 0, then VR by 2 into is VR by 2 into e power alpha x into e power minus j plus j into beta x. Yeah, so this is V plus. Okay, so therefore you substitute all these values. So VR is 76,200 by 2 e power alpha. What is the value of alpha? 0.2714 into 10 power minus 3 and beta e power j into this 1.169, I think so, 1.169 into 10 power minus 3. And if you calculate this value, you will get, yes, I told you how to calculate this complex values. Okay, yes, you will get 36.88 at an angle of minus 8 point, sorry, this is not 36, yes, I calculated somewhere, 70, yeah, it is 39.35. 39.35 at an angle of 8.02. 8.02. Similarly, what is V minus? That is reflected voltage. Reflected voltage V minus is equal to V minus is equal to S VR minus IR into ZC by 2 into e power minus gamma x as IR is equal to 0. IR is equal to 0, and x is equal to 120. So then V minus is equal to V minus is equal to VR by 2 into e power minus gamma, in the sense alpha, plus j beta into 120. Okay, now let us substitute this value. Then V minus is equal to 76,200 divided by 2 into exponential of alpha x, alpha into 120, and exponential of j into beta 120. You substitute alpha and beta. At last final, you will get the value as 36.88. So this is minus, and here also minus 36.88. 36.88 at an angle of minus 8.02 kilovolts. Yes, V plus is also 39.35 kilovolts. 39.35, that is kilovolts, not volts, that is kilovolts. Okay. Therefore, how you say, what you can say from this problem? What is your analysis? Okay. You can able to find incident voltage, reflected voltage, refracted voltage, and in the long transmission line, at any point the voltage is the sum of incident voltage and reflected voltage. So this is the concept today you learn. Yes, what is the concept? Along the long transmission line, at any point the voltage is the sum of incident voltage and reflected voltage. Incident voltage is represented by V plus, and reflected voltage is represented by V minus. Similarly, you can also analyze current. So in the current also you have incident current and reflected current. Incident current and reflected current. So from equation 10, yes, we have equation 10 in the derivation of ABCD constants of long transmission line. Okay. Yes, let me stop here. Thank you for watching this, and tomorrow the next class also we will see some more problems. And thank you for watching this. Yes, stay home, stay safe, and while you are going to the outside, take precautions, and be regular to the classes, because somebody, not all, very few people, they are not present continuously in the class, and somebody, they are not at all attending the class. So it is not like that. Just to attend the class, even though if you have the poor network, at least you attend the class. If you have the poor network, you must attend the class. Poor network, you attend the class. Wherever the network loss, so you can leave. After, whenever you have the good network, then again you can join. But don't miss the class. Okay. Thank you once again.